Hi everyone, welcome to tutorial 8. Today's our first task is about numerical integration using trapezoidal rule. So we are given an integral from 0 to pi over 4 sine x dx, and we have to compute the approximation of this integral using trapezoidal rule, and then we'll compute the trapezoidal error bound, and then we'll do the absolute relative true error computation. So let's get started. So we'll first try to use the trapezoidal rule to approximate the value of this integral. So the formula for the trapezoidal rule is for any integral of a function it is approximately equal to b minus a times f of a plus f of b divided by 2. So for our function, if we derive this, we'll get here our b is pi over 4 minus a is 0, and our function is sine x, and instead of the x we'll put the value of a, which is 0, plus we have sine of pi over 4 divided by 2. So this is equal to 0.2776818. So that's the approximated value using the trapezoidal rule. And now we will work on the second part, which is to find out the error bound, the trapezoidal error bound. So for the trapezoidal error bound, the absolute value will be absolute of the formula minus 1 over 12 b minus a cubed f second derivative of alpha. So this is equal to absolute of minus 1 over 12 b minus a cubed, and for this one value here, f second derivative of alpha, we will take the maximum of the second derivative of alpha, or the second derivative of the function, you can say. So how do we find out the second derivative of the function here? For that we need to first find out the first derivative and the second derivative. So let's work it out at the side here. The function is sine x, and the first derivative is cos x. The second derivative is minus sine x. Now we want to find out alpha, and to find out alpha we also have to find out the third derivative of x, which is minus cos x, and this third derivative of x will equate it to 0 to get the alpha. So if we equate minus cos x is equal to 0, then we have minus x is equal to cos inverse of 0. So x is equal to minus pi over 2, absolute value of which is equal to pi over 2. So pi over 2 is actually supposed to be our alpha, but here there is a problem. That is, our interval is, or our pi, you know that the alpha is in the interval a to b. So our interval is 0 to pi over 4. So alpha is supposed to be between 0 to pi over 4, so that's the upper limit for alpha, but pi over 2 is a greater value than pi over 4. So we cannot have this as the alpha because our alpha is limited from 0 to pi over 4. So what we do is we take the maximum value. So most probably you're not being able to see this. I'll just try to write it a bit above so that you're more clear. So we are limited between pi over 4 and pi over 4 is less than pi over 2. So because of this reason, because alpha is supposed to be between 0 and pi over 4 and pi over 2, which we got here, is bigger than our upper limit, so what we do is we just take the upper limit as the alpha. So here now we'll have minus 1 over 12. Our b is pi over 4 minus a is 0 cubed, and we'll take the absolute of the function sine x, and the x value will be the alpha, which is pi over 4. So this gives us the value 0.0285. So that's the upper bound of error we can have for the trapezoidal rule. Now we'll calculate the absolute relative error, and for that we need to first calculate the exact value of the integral. So let's calculate the exact value of the integral. So we have 0 to pi over 4 sine x dx is equal to the integration. We have cos x here, and we have to integrate it in the limits of 0 to pi over 4. So we'll have minus cos pi over 4 minus cosine 0, and this gives us the value 0.2928932,188. Now that's the exact value of this integral, so we can find out the true error now, which is 0.29288932188 minus the approximated value that we received was this number here. So that is 0.277,68018. So this is equal to 0.0152130881. And then if we want to find out the absolute relative true error, that would be equal to true error divided by the true value times 100. So that is 0.015 2130,881 divided by 0.2928,932,188 times 100, and that is equal to 5.19% relative error.